So here, as we said, okay, we determined the information about the different points, and now we can start to go to our tables. Now, what is required from us in this problem is to determine the efficiency of the cycle, okay? And to calculate the efficiency, I should apply which relation? So I have W net over Q input, okay? So I have that uh, efficiency equals to W net over Qn, okay, which is equal to W turbine minus W pump, okay, over Qn, okay. Now, so here, just to tell you, when I put minus WP, I just consider I am taking absolute value for W turbine and absolute value for W pump, okay? And if you want to treat them as algebraic values, so you can put WT plus WP. Then in this case, you should replace WP by a negative value, okay? So first, as we said, let us determine characteristics of each point. To start with, we will start by first point, okay? Now, look, always, okay? When you deal with a circulating fluid, then you can use the following formula for a liquid. Keep it in mind. Work in general, I told you last time, when you have a circulating fluid, the work is computed by minus integral VdP. Okay, but you know that for a liquid, the variation of volume per specific volume, which is the volume per unit mass, is very small because it's a liquid. So we assume because it's a liquid that V is nearly constant. So for when we have a liquid state, so here work done by pump, okay, on liquid state can be computed simply by since V can be treated as a constant by V minus V delta P, okay, delta pressure. And I will tell you why I will use this formula, because as you know, here you have liquid state 1 and 2 is in liquid state, and last time together when we went through the steam tables, we have seen that compressed state is not tabulated. It's tabulated only for very high pressures. Okay, so you will not find in tables the state 2. Because you are not able to find in tables the state 2 in order to compute H at point 2, what we will do is we will use this alternative formula that the work in the pump can be computed as minus V delta P. Okay, and in this case, you can write the work in two ways. So work in pump is equal to minus V times P2 minus P1, okay, P2 minus P1, and you will obtain in this case a negative result because you are using the convention that work is negative when we given on the system. So it's equal to H1 minus H2, okay. So when you calculate V delta P, then you will be able to find what? Find H of point 2, okay. So in case you need H2, you can find it using the following strategy. So H2 is simply equal to H1 plus V, which is the specific weight of the liquid, times P2 minus P1, okay. So always when you have a liquid, use the following formulation, okay? Because as I told you, in compressed tables, you don't always find your data if you don't have very high pressure.
I have a question.
Yes.
Can we approximate the H2 by HF at P equals 2 and PA?
Look, it's you can do it, but it's not a very accurate. It's not very accurate. You know why? Because the temperature is much smaller. Okay, so it will give you a value, but not yani, not very accurate. So it's preferred to be very accurate to use the other strategy. Okay.
Okay, thank you.
Well. Okay, so as we said, the first step is to find the specific volume for the liquid, which we can get from the saturated liquid column. Okay, so as we know that for point one, it corresponds to 10 kilopascal, which is pressure at the inlet. And as we said, it corresponds to saturated liquid phase. So you can see from here that you can select for the specific volume a value of 0.00101. Now, next step, okay, is to find H1, because you know that to calculate your values after, okay, to calculate your different Q and W, you need to find the enthalpies. Okay, so to find H1, also we will use the saturated water pressure entry because they gave us the pressure inlet. So we go now to the table of enthalpy, which is different from this one, because remember you have one table which give you the specific volume, the internal energy. In general, internal energy we don't use it here because if you remember we said we use it a lot in uh, not in circulating fluids. Okay, so before we were using the internal energy when you have a let's say a moving boundary, or when you have constant volume, for example, you use U, internal energy. But whenever you have a flow that is entering and leaving, if you remember, we derived together that we need U plus PV, which is the enthalpy. Okay, this is why in power systems and power plants where we have circulation of a fluid, in general we use the enthalpy because it's U plus PV, so no need for U. So from this table you get specific volume, and going to another table you can get enthalpy. So here you have at 10 kilopascal you have the value. You need to find H1. So to find H1, it is at HF. So it's HF. You get that H1 is simply 191.81. But you will see also that we will need this table again. You know why? Because we will use this table again to find properties of point 4, and we will see why. Why? Because look, point 4 is on which line? It is on the line of pressure equal to 10 kilopascal. Okay, so in this case, when we have a pressure of 10 kilopascals and we need the quality, to find the quality, we need table of at 10 kilopascals, the saturated table at 10 kilopascals. So what we will do is after we find S at point 3, which is equal to S at point 4, we can compute what is the value of the quality X4, and then we can deduce the value of H4. Okay, so we will go back to this table after finding S3. Okay, so now second step. So let us do our calculation step by step. So as we said, first we take the control volume of the pump, and since it's a liquid, we will use the formula that W pump is H2 minus H1. Now look, because you considered here they are considering this is the absolute value of WP. This is absolute value. So here, if you want, they are considering that we take the absolute value of each part, and after, when we want to calculate the efficiency, we do W turbine minus W pump. Okay, so do what you want, just understand what you are doing. Okay, so here, because we did H2 minus H1, then we are taking the absolute value of W pump, and we will do then equal to integral VDP, not minus, okay? Because if you are using the convention of W negative, then you put minus integral VDP. But if you want to find the absolute value, then you do integral VDP, okay? So first here, to find WP, which is integral VDP, we need to find V. This is V1 from the table that we got. So we replace V1 and we have P2 minus P1. We can find W pump, okay? And now, once we find W pump, as we said together, we can compute now H2, which is H1 plus WP, and we get H2, okay? And here always, as I told you, whatever is the convention you take, keep in mind to verify your results. So as expected, at the exit state from your pump, the enthalpy should be higher because you are compressing your fluid. So H1 was 19.8, H2 will be 193.8. So as you can see, and as I told you before, the work of the pump is really small, okay? And this is an advantage because we are, this is a loss for us, okay? Because we need to provide this to the system. So since you want to provide this work to the system, it will be good to have a small work, and this will increase the efficiency because W net will be higher, okay? Now, let us continue. The second step after the pump, what do we have? We have the boiler, okay? So now the second control volume to take is take the control volume of the boiler. For the boiler, we need to compute the heat input in the boiler. So if we write the energy equation for the boiler, okay, so which is, let's say, a Q. If you want to use this convention, as your friend said, everything in is positive, everything out is negative, we will put Q plus W equals to H outlet minus H inlet, okay? But for your boiler, no work, so W you can cancel it. You only have Q of boiler equal to H out minus H in, so Q boiler is H3 minus H2, okay? Now we need to find H3. But for H3, as we have seen together, no problem. Why? Because they told us that it's saturated vapor. So going back to this figure, I have all what I need. I have the pressure 2 megapascal, and I have the state saturated vapor. So I want to take which H now? Hg. Okay. So now I will go to the saturated table of 2 megapascal. So when I go to the saturated water pressure entry, I select 2 megapascal, okay? So taking 2 megapascal, I can read the value of saturated vapor Hg, which is here, 2799.51. So I got H3 and I have H2. By doing H3 minus H2, I can then calculate the value of my heat input in the boiler. Okay. Now, for point 3, we need also to find entropy of 3. Why? Because when we calculate S3, we can use it for S4 after. Because as we told you, as we did together, we said that point 4 is characterized by the same entropy of point 3. Since I need after to determine the state 4, I need to get from this table also not only Hg used in the boiler calculation of heat, but also I need to find Sg, which correspond to S at point 3. So I will take the entropy at the saturated vapor, which is 6.3408, and I will only need it to determine what? To determine state 4. So I can directly say now that for state 4, S is 6.3408. Okay? And knowing S4, I can calculate now the quality because I know that it's a combination mixture of vapor and liquid. At which pressure? Go back to your figure. Point 4 is at the low pressure, which is 10 kilopascal. So now I should go back to the table of saturated water, okay, at 10 kilopascal. So This is saturated water pressure entry at 10 here, at 10 kilopascal. And from this table now, I will be interested in which values, in values of SF and SFG. Why? Because I can write that S4, okay, S at 0.4 is equal to S saturated liquid, which is notated as SF, of course at 10 kilopascal, okay, and the plus what? Plus the quality X4 times H times SFG, okay, and of course also SFG at 10 kilopascal. So now, since I know S4 and SF and SFG, I can get them from the table. Okay, I can calculate now X4 because I can write simply that X4 is equal to S4 minus SF over SFG. Okay, so let us replace. S4 was nearly 6.3, I remember. So let us put the actual value. It's from here. It's 6.3408. Okay. So 6.3408. Okay. And minus SF. What is SF? SF here, you can read it here. It's 0.6492 minus 0.6492. And we will put brackets here to, okay, over SFG. You can read SFG from here, 7.501. So now I can get the quality X at 4. And once I get the quality at 0.4, I can calculate what now? I can calculate H4. So H4 is simply HF at 10 kilopascal plus X4 times HFG. Okay, and I can read the value of HF and HFG here. So I have HF is 191.81 and HFG is 2392.82. Okay, so now going back to my problem. Okay, here I was at the boiler. I calculated H3. I found H3 from the table. I can calculate Q input in my boiler. Now, next stage is to go to my turbine. Okay, so for my turbine, I know state 3. Okay, and I know the pressure, and I want to find state 4. So to know the work produced by my turbine, I need to get H3, H4. So my work done by my turbine is H3 minus H4. So if you want, as you can see here, they are dealing with absolute values always. So when they say WT, they calculate the absolute value. When they find WP, they calculate the absolute value. And then after, when they calculate W net, they do W turbine minus WP. So also it is another strategy. At the end, you should understand what you are doing, okay? And you will get the right result. So because they are taking this convention, so now for W turbine to be positive, they do H3 minus H4, okay? Because H3 is higher than H4 since your turbine is producing work, okay? So you should take H inlet minus H outlet. While for the pump to obtain a positive work, you should take H outlet minus H inlet, okay? So as we did together, to find the quality, to find the enthalpy at 0.4, we need to use that entropy S3 is equal to entropy at 4. And after this, from this relation, we calculate X4, which will be used into the computation of H4. And once we find H4, we can find that W turbine is H3 minus H4. We get the result. Okay. And now we have computed the work of the turbine, the work of the pump, the heat in the boiler. So now we can find the efficiency. We have everything needed for the efficiency. Our efficiency, we can calculate our efficiency in several ways. Okay. Now here, what they did before going to the efficiency, they calculated. If you want just the efficiency, no need to find Q condenser. Okay, because your efficiency can be defined in several ways. It is W net over QH, which is W turbine minus W pump over QH. Or if you want also, you can say that because I have a closed system, then I can say that sum of work, so sum of work equals to sum of heat. This is why W net of my system is equal to QH, okay, minus Q condenser, Q lost. Okay, so if you want to use the other approach, then you can calculate also Q condenser, and in this way you can verify your calculation also. So to find the heat loss at the condenser level, so as I told you before, because we have when we put QL, so it's lost, then we put a positive value. So Q lost is H at 0.4 minus H at 0.1, and it is 1,815.7 kilojoule per kilogram. So now you can calculate your efficiency in two methods, and of course you should get the same result to make sure that you don't have calculation errors. So you do W net is W turbine minus W pump, and for Q net it's Q in minus the Q lost, so the input minus the loss. And if you do both, you will end up with the same result for the efficiency. And just to a small remark, if you look here, if you compare W turbine and W pump, you can see how W pump is very small compared to W turbine. This is why sometimes they neglect it. Okay, they say no, it's very small compared to it, so it's not a big error if we neglect. Okay, any question?
Miss, in the exam, because it's MCQ, you're going to give us مثلا, a part of a
yes, exactly. So I will
part
not give
of this
you a whole
problem.
problem, but I can just, for example, give you a problem like this and just ask you calculate the work produced by the turbine, for example. Okay, or calculate, let's say, H at 0.4.
Okay, for the tables.
Yes.
You said you were going to send the link. Did you send it? Did you send
yes,
it?
I did. Yes, I posted
Where?
it in the links. I think with YouTube link,
Okay.
maybe.
Okay, thank you.
Okay, and please
Doctor?
download it before it will expire.
Doctor,
Because it's WeTransfer link.
the exam will be MCQ?
Yeah. Look, for problems, it's not MCQ. For problems, you input.
Because we need partial grade.
Yeah, of course, partial grade, of course. What you will do, you will write your solution on a draft, okay? And the draft is more important for me than what you put on Moodle, because I will correct your draft. So please, I don't want to see different answer on Moodle and draft, okay? And the order of question will be random. So you will not have the same questions of other friends at the same time. So please focus on your exam and don't lose your time with others, and you will do well if you study. Don't worry. Okay?
And is it sequential, or we can go back to previous questions?
No, we can't go back. Okay, we can't go back because in online exams we should to minimize cheating. This is the strategies we are doing. We give a limited time. We give questions in random order, and we cannot go back. But believe me, if you study well, you will take a very good grade. So don't worry. Just I don't care for your answers as much as for your method. So if you do the right method and you have calculation error, I will give you 90% of the grade. So write your method.
How do we give you the draft?
Directly when you submit, directly after the exam, you take photos and you send me by WhatsApp private message. So each student will send me his draft privately, and he will give me his name also, so I will correct for each draft.
طب I can kill every question that we have. We should write a draft to it.
Yeah, of course. You should write your draft. I don't accept answers without draft. So don't tell me I did it in my mind. No, I will consider that you copied the answer. You should write everything, even if it's very simple. If it's one line, write it. So I should see the method you used. Okay. So you should write everything. Okay, some questions. Let's say I will ask some questions on knowledge. So for example, let's say. For example, what is the dominant type of heat transfer in solids? I will give you conduction, convection, let's say radiation. You will choose what? Conduction. Okay, this one, no need to justify. Yes?
Okay. How do we know which one we need to justify or no?
When you have calculation, of course.
Okay, thank you.
Okay, so whenever you have calculation, you should justify by a draft.
دكتور الجنرال نولج رح يكونوا يعني هذا الباوربوينت اللي بالاول انه just take general information عن
energy sources just understanding equation understanding questions يعني just testing concepts. I will not ask about dates, I will not ask about very small details. No, overall, if you understand the concept and if you read at least 1 or 2 times the slides, you will be able to answer. So no need to memorize anything.
Okay.
Just to understand. For example, if I tell you like the question I gave you, you don't have to memorize because
no, of course.
Okay, in solids, the dominant mode is conduction. We have talked a lot about it. We have done a lot of problems on it. So that's it.
Okay. Thank you.
Okay, welcome. Any other question? So please download the book. I posted the link for you, and I will send you also the correction of assignment 3. But try to do it on your own to see what are your problems. And if you face any problem in solving, you can directly text me by WhatsApp message. Doctor? And if you need office hours, I can also anytime you want we can do office hours.
Doctor, yes. The exam will be proctored?
Yes, I will open. I will use WebEx for proctoring because it's unlimited in time, and I will proctor you. You will put your cameras on, and if you need anything, then during the exam I will be available to help you. And when you finish, so when time is out, you should all submit at the same time. And in case you face connection problems, you will directly tell me. You take a screenshot of your computer, you send to me, and I will follow up with you. Now I will try to do several quizzes so that if you face connection problems, it will not affect your grade. So don't worry about it. Maybe we do, let's say, if we do 3 quizzes, we do drop the lowest. I will see. Let us do the first quiz to see how it will go, and then we decide.
Okay, thank you, Doctor.
Okay, thank you.
Welcome.
Doctor, we have everything up till now, Mahek?
Yes, everything until now, yes.
Okay.
So next time, it's not included. The lecture will do next.
Okay.
Okay, so, thank you.
Welcome. See you next time.
I have a question.
Yes.
About the paper and the presentation, the due date is November 30, and you have to present on November 2nd. The PowerPoint.
Yes, you should do a PowerPoint, okay, and present your work. Now, after we finish the exam, we will set dates, for groups, for different groups, and then each group will do its presentation, and the report will be already sent to me before the presentation.
Okay. Thank you.
Welcome. So we said that I think we agreed on giving me the report in the 3rd week of November. Yes, this is what I remember. So the exam is on 14, maybe on 21, you should send me the reports. Yes, this is what we agreed on.
Yes, 25.
25.
Doesn't matter. Yeah,
Okay, it's fine. It's fine.
thank you.
Right.